Alright, for the warm-up here, number 1. Sam, what did, there's a couple ways to do number 1. What's the first thing you did for number 1? Distribute, yeah, working with PEMDAS here, so you distributed the 5, right? 5 times 50 gave you 250. Oh no.
I think it's okay.
Got it.
I think.
5 times 50. And then you distribute the 5 to the 2 to get 250 plus 10 gave us 260, yes. Alright, number 2, 18 plus negative 25. Hey, did you get this one? Negative 7, nice. And then 3. What is the difference between a daily low temperature of negative 5 degrees Fahrenheit and a daily high temperature of 18 degrees Fahrenheit? So somewhere in the winter time when we're dealing with negative temperatures, we're going to start at negative 5 and have a daily high of 18 degrees. What is the difference between those two temperatures? Got it. 23, yes. Because if you draw it out here, kind of draw our thermometer here, we have negative 5 degrees down here. We'll have like our origin or 0 here and going up to a daily high of 18 degrees. So we're going up 5 to 0, but then another 18. So it's kind of like 5 going up 5, 1, 2, 3, 4, 5 hitting 0, and then counting another 18 to have a difference of 23 degrees Fahrenheit. Favorite question. How do we do number 2? So if you type this exactly in your calculator, if you have a graphic calculator, 18 plus negative 25, that's going to give you negative 7. So think of it as like a number line. You're starting here at negative 25, right? And then you're going over positive 18. So if I went over here on a number line 18 times, what am I going to stop at? Negative 7. Does that make sense if you think of it as like using a number line? Yeah. Okay.
Anyone else have questions on the warm-up problems? Good. So we're going to talk about the different types of numbers. Starting with real numbers. Does anybody know what the other type of number is called if it isn't a real number? Kind of is like a fake number. It's called an imaginary number, and imaginary kind of does mean fake. But there really are like imaginary numbers that exist. You will do those if you take Algebra 2 next year, if you're a junior, and you're going to take another math class. You'll see some of those imaginary numbers.
Yes, ma'am. So I'll be a senior next year. Do I have to take another math?
Not unless you're college bound. So if you're college bound, then yes. That's like a whole year away. By the end of the year, I might convince you to take a math class anyway, because you just love math so much all of a sudden. So we're going to look at real numbers today. And when you have a diagram like this, as you work your way down the diagram, the numbers or whatever you're dealing with gets more specific, and usually there's less of them. So real numbers, there are a ton of real numbers. We're going to try and break that down into the different types of real numbers that exist. So the first type down here, this will be like the second largest thing underneath this bubble, is called a rational number. So you have this whole huge, like all the numbers we've worked with so far are called real numbers. Underneath that, if we start to break it down, there's something called a rational number. And a rational number is any number that can be written as a fraction. And when I use this symbol here, what's this symbol mean? Number, right? Not hashtag, not math. Number. So any number that can be written as a fraction. Just say written as a fraction. Okay, so what does that mean? Any number that can be written as a fraction. Well, can any number be written as a fraction? So if you start out with a number like 0.75, that's a decimal. What's that decimal written as a fraction? 3/4. So it's allowed to be in decimal form, but you have to be able to take a decimal and make it into a fraction, and not all decimals can be written as fractions. So 0.75 is the same as 3/4. And there are a ton that can be changed from decimal to fraction. That would just be an example. So looking to the right of it, if it's not a rational number, it's called irrational. So anyone want to take a guess what kind of number that would be? It can't be written as a fraction. So last year, when you were doing area and perimeter and volume, did you do volume last year too in geometry?
Yes.
Yes. There was a common symbol that you used in all those formulas, Tommy. Do you remember what that common symbol was?
No.
What symbol did you use a lot last year in geometry that was in those formulas? Especially talking about like circles. Somebody say? Pi, yeah. Pi is considered an irrational number. It's fake, right?
Yeah.
Yes. Do you remember what pi represents? 3.14, but then it doesn't stop there. If you plug it in your calculator and you hit the pi button, then it spews out like 12 other numbers after that, and it just keeps on going on and on and on. So it's irrational. It can never be written as a fraction. Another number, like square roots, a lot of them are weird decimals. The square root of 2. Anybody know how to put that in the calculator where the square root button is? We'll be using that square root button. So if you find that square root button, it should be second x squared. What is the square root of 2? Not 4. Square root of 4 is 2. Sarah, I think you just plugged it in your calculator. What did you get when you put in the square root of 2?
1.41.
Yeah, 1.41. And then it goes on forever too, right? There's a whole bunch of numbers after that. So that's another example of an irrational number. And there's a whole bunch of them. But they're just like numbers, usually square roots, like the symbol pi, but just different numbers. It could be just a crazy random fraction. Make up your favorite numbers. I don't know. I just kind of writing some numbers here. That could be an irrational number, as long as you can't convert it into a fraction. All right, so after the rational and the irrational numbers, anybody know what other types of numbers there are? Begins with an I.
Irrational.
Well, besides irrational. So we have rational and irrational,
Illegitimate.
and underneath that, there's a different type of number.
Integers.
An integer, yeah. So integers are a little more specific than rational numbers. Integers can be positive and negative, but they're only positive and negative whole numbers. So 1, 2, 3, 4, -1, -2, -3, -4. 5, -7, 15. So they're allowed to be positive and negative, but they're not fractions. They're not decimals. And then the last type of number, which they would be the least of, are just the whole numbers. And a whole number starts at 0 and it just goes positive. So those would be the whole numbers. Only positive. So throughout the year, we'll be working with many different types of numbers. You'll see those terms being used, so that you can hopefully maybe kind of like recognize what it means if it's talking about an integer versus a whole number or a rational number. Questions? So what we're going to do today is we're going to take all these types of numbers and try and graph them on a number line. Look at which one would be larger or smaller, and graphing them in order from least to greatest. Which is why at the bottom we've got a couple of other words before we start looking at some examples. The first one is a number line. You will be graphing, I don't know, maybe like 6 or 7 problems on number lines tonight. I have number line graph paper, so you don't have to worry about drawing it, but you will have to label it. When you're labeling it, you do need to start with a negative number. They should increase in order from the least to greatest. You shouldn't skip any numbers. So it just goes -4, -3, -2, -1, 0, and then it starts to increase with the positive numbers. So it shouldn't jump around like have a -4 and then a 1, and then a -7 and then an 8. Like it needs to go in order, starting with the smallest number. But on a number line, what's the origin? 0, yeah. So 0 on the number line is the origin. And a coordinate is a point that corresponds with the value on the number line. So if you have a calculator with you, you might want to pull it out so that we can plug in some numbers into the calculator. We're going to graph some number lines. So we're going to look at graphing some things on the number line. We'll look at a little word problem that goes along with them.
All right, example 1, graph the real numbers, -5/3, the square root of 2, and 2.6. So looking at those 3 numbers there, what's the first thing we can do before we graph those numbers on the number line? First thing we want to try to do. Ben, do you know? We want to try to simplify them, but put them in what type of form?
Numbers.
Pardon me. Decimal form. Good. Yeah, so -5/3, if you have your graphing calculator, decimal form there goes to -1.6. Okay. And then square root of 2. Let's put that in decimal form. Go ahead, Tom. Maddie, do you have square root of 2 in decimal form?
Yeah, 1.41.
1.41. And then 2.6 is already in decimal form. We're in good shape there. All right. So graphing -1.6. Repeating. I'm going over here on the number line. -1.6 is between -2 and -1. I'm going about right there. Drawing my coordinate. And then I have 1.41 going in between 1 and 2, drawing my coordinate at 1.41. And we can label these two, -1.6 repeating, 1.41. and then over to 2.6 between 2 and 3. Graphing those three. Zach.
May I use the restroom?
Any questions on that one? One more. Oh, Example 2. So graph the real numbers, -1 and -4, then compare them using the symbol less than or greater than. Alright, now we look at -4 and -1, and we see 4. 4 is bigger than 1, right? But be careful here. So if we're going to compare using the symbol, we have -1 and -4. Is -1 greater than or less than -4? Good.
Greater.
Maria, right?
Yep.
All right.
Greater than.
Greater than, yeah. And similar to the warm-up problem we did, if we look at -1 on the number line right here, okay, graphing it, -4. Sorry. -1 is closer to our origin, right? Three. The table shows the record low temperatures for 5 months at the South Pole. Use a number line to order the temperatures from lowest to highest. First thing, let's find our lowest temperature. What's our lowest temperature there? Megan, what's our lowest temperature? -117, June. Okay, so I have -117, and then my warmest temperature, what is it, Megan? Warmest temperature, -108. Now, I have to draw a number line in order from lowest to highest. We can't start at 0. The numbers are too low. Going from 0 to -117 is just going to be too much. Okay, so let's make our number line. I found my lowest temperature at -117. I'm going to start there. And I can probably count by ones going up. So let's go -116, -115, -114, -113, -112, -111, -110, -109, and -108. Alright, and now I'm just graphing my coordinates here, starting with May, -109. We can write May up there. My lowest temperature in June, -117. I can label that June. July, -113. July. August at -108. And then September at -11. Questions? I think the hardest part is figuring out what to count by on your number line. Whether you're going to count by 2s or 3s. Alright, that was 3. And then bottom of 3. Oh, you had a number line drawn, Miss Keen.
Yeah, it's just gonna
Okay. Do you want me to go over 2 terms? Okay, so 2 terms here, opposite and reciprocal. If we have opposite numbers, what are like 2 opposite numbers?
Positive and negative.
Good, Tommy. Positive and negative. So let's make 2 up.
Negative and positive.
Yeah. -2 and +2 would be opposite. Alright, you have a negative number, positive number. You have -3 again, 3. And reciprocal. Okay? Anyone want to try that one? We're just flipping. Okay? So if I have the fraction 1/2, the reciprocal of that would be 2/1. Miss Kane said this morning, if you're finding the reciprocal, it's like flip to find the recip. That's how you kind of remember that term. Flip to find the recip. Another example would be if you had 3/5. The recip of that, 5/5. Questions? Any more on that page? Done with page 4?
Oh, those are long, they were at the bottom, the last set of
Nice. Alright, take a couple minutes, example 4. A and C are probably a little bit easier than B and D. And then we'll go over those 4 together in about 2 minutes.
What's a
Result obtained by dividing one form
Is that your iPad or just
the red one. So what I do is,
Can you put it away?
you know,
Hey. Can it fit in your pocket?
once you can,
Really?
I'll try to put out all this in.
easier geometry?
So that means
It looks like B and D are definitely a little trickier than A and C.
A lot of no tries on B and D.
Mm-hmm.
Alright, find the difference of 4 and -9. But first we gotta know, what's difference mean when it says find a difference? What are we doing there, Bella?
Well, I added them.
You added them? Well,
Well, negative.
Good-
Well, to find
good, I
the
know what you mean. So you got 4, find the difference of, which is subtract, right? -9. But when we see 4 minus a -9, what are we doing?
Well, you're subtracting, but well, you add them.
Right, so if you see minus a negative number, you have to add. 4 plus 9.
13.
Find the quotient of -15 and 1/3. Quotient. Zach, do you know what, when it says find the quotient, what are we doing? We're dividing, okay? So you can take -15 divided by 1/3, or you can multiply, okay? So in your calculator, it'll be a little bit tricky if you did -15 divided by 1/3. Make sure you're using parentheses if you're doing it that way. But the other way to do it is you flip 1/3. You find the reciprocal here. So it's actually negative 15 times 3 over 1, which is 3 over 1 is still 3. And then Zach, negative 15 times 3 gives us negative, there you go. 2 ways to kind of solve B, depending on what calculator you have and what's easiest for you. Maria, find the difference of 3 and negative 6.
9.
Same thing. So we got 3 minus a negative 6. Well, really, we have to add those two to get an answer of 9. And if you could do B and D very similar, find the quotient of negative 20 and 1/4. So negative 20 divided by 1/4, or flip it, multiply, we have negative 20 times 4. Tommy, negative 20 times 4 gives us negative 80.
Anyone have questions? So, with the last 5 or 6 minutes in class, I'm going to kind of set up the homework for you. You can do everything on this piece of paper. It's just graph paper for number lines. Again, take your book home, keep it at home. We have a class set of books in here that we can use, but just to kind of get you started on the homework. Homework is always written on your assignment sheet. It's also on the board right next to Zach. And that homework assignment is on pages 6 and 7, and then it's numbers 21 to 29 odd. So pages 6 and 7, 21 to 29 odd. And then it has 33, 35, 36, 38. Those are all going to be like a little bit of a word problem. And then the last group, 51 to 57, are like the ones that Mr. Long just went over, and odd again for those. So I wanted to start number 21 with you. So in number 21, the problem wants you to graph two numbers, see if I can get my book on here, on the number line. And you're graphing 0.6 and 2/3. So we're looking at 0.6 and 2/3. That's what number 21 is asking us to graph. Because those numbers are pretty small, if you just start at the 0 in the middle, so kind of find what looks like the middle. You don't have to label all of the number line. Make sure you just have a couple of values labeled down there. But 0 in the middle, to the right should be positive, to the left should be negative. You shouldn't be skipping any numbers because the numbers aren't huge. And then you're graphing 0.6. 0.6 is in between what two numbers? 0 and 1. So right there is 0.6. Anybody know what 2/3 is as a decimal? Anybody plug it in the calculator? What's 2/3 as a decimal? It's 0.666666666666667, which is literally right smack dab next to 0.6. So that's what number 21 should look like. So you've got those 2 points that are almost on top of each other, but 2/3 is a little bigger than 0.6. So then the rest of your homework, you're gonna have a problem just like that. So please write the problem above the number line so that we can kind of see what you're graphing, to know if you're graphing it correctly. The homework will be collected tomorrow. Typically, we do collect it, especially at the beginning of the year, just to kind of get into the habit of doing the problems. Minimal work showed here, I really didn't show any work besides converting the 2/3 into that decimal form. Anybody have questions? So again, take that book home with you, keep it at home.
For the 1 to 33 to 38, should we do one separately?
No, just do them at the bottom or do them on the back.
Do any word problem?
It's just one word problem, it still involves graphing with another
51
line.
to 57, early community.
No, they all won't be this.
What's this?
Those ones are the problems like the last one where it says find the difference of 5 and negative 7. You can use the calculator, you can put it on the back or you can just use them on the back. That's fine, you're good. So calculator tomorrow, pre-course test. Bring in that parent guardian form 2 for me, please. Have a great day, nice job.
So,